Hey, science explorers! Welcome back to Funimation 3D, the coolest place where we discover all the amazing things in space and beyond. I'm your host, and today we're going to explore one of the wildest weather events in the solar system, Mars dust storms. Have you ever wondered how an entire planet can look like it's disappearing behind a giant cloud? Let's blast off and find out. Whoa! Get ready for a big space surprise. Imagine looking at Mars through a telescope and suddenly, it fades like someone pulled a giant curtain across the whole planet. Not because the lights turned off, not because Mars went away, but because the air fills with swirling dust so thick it can hide mountains, block sunlight, and make the red planet look like it's wearing a dusty blanket. That is a Mars dust storm, and some of them can grow so huge that they wrap around the entire planet. Wow, right? Picture this. Mars is already famous for being red, but the red isn't just a paint color. It comes from rusty dust, kind of like tiny bits of iron that have turned reddish, like metal left out in the rain. Except on Mars, it's super dry. Mars dust is not like the sand at the beach. Beach sand has bigger grains you can see. Mars dust is more like flour or cocoa powder, so tiny that if you puffed it into the air, it would float and drift and sneak into every corner. And Mars dust has a sneaky superpower. It can get electrically clingy. If you've ever rubbed a balloon on your hair and made it stick to a wall, that's electricity from rubbing. On Mars, dust grains can bump and scrape and build up that kind of static charge. That makes the dust extra good at sticking to things. It can cling to rocks, cling to robot wheels, cling to solar panels, cling, like the planet is covered in invisible sticky tape. So why does Mars get these giant dust storms in the first place? Let's compare Mars to Earth. Earth has thick air, lots of water, and rain that can wash dust out of the sky. Mars is different. Mars has a very thin atmosphere, which means the air is much lighter and less dense, like a super weak version of Earth's air. You might think thin air means weak storms, but Mars has tricks. First, Mars is dry, super dry. No oceans sloshing around, no rainy days to clean the air. The surface dust just sits there, waiting. Second, sunlight warms the ground during the day, and when the ground warms up, it warms the air above it. Warm air wants to rise, like hot air from a toaster. Rising air can create winds, and winds can scoop up dust. On screen, we see the sun shining on the red ground, and heat waves shimmering like you might see above a hot road in summer. Now add one more ingredient. Mars can have strong winds, especially when seasons change. Even though the air is thin, winds can still move fast. And because the dust is as fine as flour, it doesn't take as much push to lift it into the sky. Once dust starts floating, it can absorb sunlight and warm the air even more, which can make the winds stronger, which lifts more dust, which warms the air even more. It's like a snowball rolling downhill, except it's a dust ball growing across Mars. Not all dust storms are the same size. Some are small and local, like a dusty whirlwind dancing across a field. Imagine a tiny tornado made of dust, spinning and skipping along the ground. These can happen in just one area, and they might last minutes or hours. Then there are regional storms, which are bigger, covering a large part of Mars, like a whole country-sized patch of dust in the sky. And then there's the grand boss level, global dust storms. Those are the planet-wide storms that can spread until Mars looks like it's been wrapped in a hazy, dusty cloud from top to bottom. Imagine a globe of Mars on your desk. Now imagine dust storms spreading like spilled powdered sugar. A local storm is a little sprinkle. A regional storm is a big, messy spill. A global storm is when the entire globe looks dusted over, like someone dropped a giant bag of flour on it. That's how Mars can disappear behind its own dust. What happens during a global dust storm? First, sunlight gets blocked. The dust acts like a blanket between the sun and the ground, but it's a weird blanket because it can make different places warmer or cooler in different ways. If the dust blocks sunlight from reaching the surface, the ground can cool down. But the dust up in the air can absorb sunlight and warm the atmosphere higher up. So Mars can get a kind of temperature shuffle, cooler down low, warmer up high, like a layered cake of temperatures. And the sky color changes. Mars already has a dusty sky, but during big storms, it can turn extra hazy. More orange, more reddish, like looking through fog made of cinnamon. Picture this: a rover looking toward the horizon and seeing the sun as a faint, blurry circle, like a flashlight behind a thick curtain. The world looks softer, dimmer, and dustier. Now, let's compare Mars storms to Earth storms in a fun way. On Earth, powerful storms can bring rain, thunder, lightning, and big clouds full of water. On Mars, there's basically no rain like we know it. No ocean waves feeding huge rain clouds. Mars weather plays by different rules. It's a dust world, not a water world. Also, Earth's thick air can push hard because there's more air molecules bumping into you. Mars has fewer air molecules, so even if the wind is moving fast, it doesn't shove with the same heavy force. But here's the catch. Mars dust is so tiny and so dry that it can still be lifted and carried easily. So the wind might not feel like a giant punch, but the dust can still behave like a swarm of powder in the air, filling the sky, covering surfaces, and reducing sunlight. That brings us to the brave robot explorers on Mars. Mars rovers are like tough little science campers. They drive, drill, scoop, and take pictures, all while living in a dusty desert planet. But dust storms can be a challenge, especially for robots that use solar panels. Solar panels are like leaf-shaped power collectors. They turn sunlight into electricity. If a storm blocks sunlight, they collect less power. If dust sticks on top, they collect even less. It's like trying to charge a tablet with a blanket over the charger. One famous rover named Opportunity explored Mars for many years. Opportunity was powered by solar panels, and it worked far longer than anyone expected, like a champion marathon runner on wheels. During a very large dust storm, the sky got so dusty that sunlight became too weak for its panels to recharge enough. Opportunity went quiet, and even though teams on Earth tried to listen and call out, it never came back online. That's a little sad, but also amazing, because Opportunity taught us so much and survived for so long in a tough place. It was a hero robot that helped us understand Mars better. Other missions learned from that. Some rovers use different power sources, and many have clever strategies to handle dust. They can tilt panels, conserve energy, and wait for skies to clear. Sometimes, little gusts of wind can even clean panels off like a surprise broom. Imagine a dusty robot getting a natural wind shower that brushes the dust away. Mars can be rude, but sometimes it's helpful too. So how do scientists know when storms are coming? They don't just guess. They watch Mars with orbiters, spacecraft that circle the planet from above like flying cameras. Orbiters take pictures of dust clouds spreading. They measure temperatures and look at how sunlight is being blocked. They track patterns over time, like a weather report, but for another planet. Think of it as space weather forecasting. Scientists also pay attention to Mars seasons. Yes, Mars has seasons, because it tilts like Earth does. During certain seasons, Mars is more likely to stir up dust. When sunlight hits different parts of the planet more strongly, it can change winds and heating, and that can make storms more likely. On screen, we see a calendar of Mars seasons flipping like pages, while dust swirls grow and shrink on a map of the planet. Now let's do a quick fun recap game. Get ready. 3 questions. Question 1. What is Mars dust like? More like beach sand or more like flour? Question 2. What makes global dust storms so dramatic? Do they bring rain or do they block sunlight like a blanket? Question 3. Who helps us predict Mars storms? Mystery wizards or orbiters watching from above? If you answered flour, blanket, and orbiters, you're thinking like a real space scientist. So here's the big takeaway. Mars dust storms are wild because Mars is dry, dusty, and heated by sunlight in ways that can build powerful winds and giant dust clouds. The storms can start small, grow huge, and sometimes wrap the whole planet in a hazy orange-red veil. They challenge our robot explorers. but they also teach us important lessons about how weather works on different worlds. And every time we learn, we get better at exploring. Like this video, share it with your friends, and subscribe to Funimation 3D. Keep looking up and stay curious!